that you should not be able to access that batch button, but you will have the star rating system at the bottom of the presentation page. Yeah, sorry for that. You will have the star rating at the bottom, so please use it, and also please fill the feedback form. It will help us to improve and make us better in the future. Just a small word from my side. It's not the first time that we are doing a talk for our community, but someone has the microphone.
Colleagues, please unmute your microphones. Mute your microphones.
Right. Yeah, as I was saying, this is not the first time that we are actually doing talks in this community, but after COVID situation, we are trying to relaunch this kind of talks. We are going to make a variation in how we actually do these talks. Instead of actually doing talks or presentations from time to time, we are going to try to actually keep some kind of schedule. Initially, it's going to be once a month. It will depend of our speakers' availability. Okay. I'm not 100% sure if we are going to have the talk in August. Okay, it will depend on holidays, on the volunteers, but for sure we are going to be back on September. All right. Also, some small plans for the future. Ideally, we will begin to actually this meeting that we have today is only online, right? But in the future, we will have them in a hybrid. The plans are to have them in a hybrid setup. So we are going to have them still online in the platform, but also we want to have it as a gathering for the community here in Malaga. All right. So yeah, expect to have that beginning ideally on September and on the next month, right? We have 3 talks today. The first one is going to be how to measure etcd performance on-prem and not to die trying by David Perez. David Perez is one of our senior system engineers here at EPAM. The second one, these talks are going to be fast. Okay, we would try not to make them really dense and really long. Okay, so they are going to be between 5 and 15 minutes with some time for questions and answers. All right, so the first one is going to be done by David Perez. Second one is going to be done by Juan Carlos Valderrama. The title is Dry, Don't Repeat Yourself. It's paradigm on automation, CD with GitHub Actions and Terraform. All right, Juan Carlos is one of our solution architects in the practice. Also, we have next Kirill Bogdanov. He's one of our security architects, and he's going to talk today about protecting container-based solutions in Azure, community tools against Microsoft Defender for Cloud. We are going to have those 3 talks. Depending on the presenter, we can have a little bit of questions and answers after their own presentations. But at the end of the 3 talks, we are going to have around 50 minutes if you want to ask something to ask the organization or also to the speakers. We are going to have more time at the end. All right. So if some presentation is to ask whatever you need. All right. So without just a small thing, as Katsiarina already said, she began recording the session. The sessions will publish on the platform on We Are Community portal and after the meeting. All right. That's all from my side. I hope that this is going to be the first of a lot of meetings that we are going to do in the future. I hope that the contents of these meetings are interesting for all of you guys, and I hope that they are fun, and you have 1 hour that you are going to be interested and enjoy this time with us. Okay, so the first talk, as I said, is going to be done by David Perez. It's how to measure etcd performance on-prem and not die. So David, if you want to continue, the stage is yours. All right.
Thank you. Share here. So, good afternoon, good evening, good morning. So, thank you all who took time to come today. I wanted to thank you all. And also thanks for joining this activity. As Miguel said, my name is David Perez, and today I want to share with you my own experience, something that I had faced. And even though it's not that frequent, when it happens, we should know how to react to. So pretty much I'm planning on presenting myself a bit, but then go directly into what etcd is for those of you who are not familiar with. And hopefully you can end the session with some new important knowledge about the critical component for Kubernetes. We'll then see what was the requirement that I had, and actually the problem that arose. We'll also go through what is throughput and latency in general terms, and how they heavily affect etcd. We are also going to cover a basic yet meaningful benchmarking exercise to address performance problems. And finally, we conclude with how did we manage to remediate the problem and some useful tips I learned through the way. So I hope my own bad experience actually serves you well to avoid it in the future. So having said that, I'm David. I'm a software engineer that has been in this world since 2010, breaking things while learning in the process, probably breaking more things than learning. Have worked on different platforms and businesses around 6 different countries. I graduated from a national university in Costa Rica and cannot live without animals and music. So this is me in a nutshell, but enough of me. That is very boring. So now into the topic, what is etcd? So as per etcd's official website, etcd is a strongly consistent distributed key value store that provides a reliable way to store data that needs to be accessed by a distributed system that's important, or a cluster of machines. It also handles leader elections during network partitions and can tolerate matching failure even in the leader node. So this last piece of information about the leader and the elections is done thanks to the Raft protocol, which in summary is an algorithm designed to enable a voting system across clusters to select a leader that can orchestrate the rest of the cluster members. It is very used in products like databases, where the writings should be performed to a main or leader host. Even though etcd can be used alone as a distributed key value store, it is most known for being the platform that stores the Kubernetes state. If etcd crashes, Kubernetes crashes. It's that simple because it's the state. So as seen is this in this image, etcd is solely accessed by the kube-api server for storing and reading the actual Kubernetes state. And no other application or component should directly interact with etcd. And that is nice, but what is kube-api server and what's the relation with etcd? I'm going to do this pretty quick. So the Kubernetes API server validates and configures data for the API objects. What are API objects? Pods, services, replication controllers, deployments, and others that we have in Kubernetes. So the API server handles REST operations and also provides the front end to the cluster state, etcd, through which other components interact. So as seen with the arrows, the different cluster components interact with etcd only through the kube-api server. So now, having done that brief overview of Kubernetes and etcd components, we now dive into the requirements I had some time ago. So there was a need to deploy an on-prem Kubernetes cluster without using any service that the cloud providers have. Instead, virtual machines would be created in a physical data center that the business had available at that time. So if you remember me saying that no cloud services should be used, then I meant it. All the storage was local. The product's core feature was a database, some sort of, and it must be deployed within Kubernetes. So we ended up using a Postgres Kubernetes operator to make it high available and to follow the operator pattern and reconciliation loop principles. In the need of storage buckets, some sort of S3 compatible interface was put in place so that the services could interact with the buckets. And of course, all public inbound and outbound connections were closed, so the cluster didn't have internet access at all. As soon as we deployed the first cluster, we started noticing that the Postgres cluster was restarting very frequently, and it was selecting new leaders every few minutes and connections being dropped out of nowhere. Of course, the first thing we thought was to troubleshoot the Postgres operator, which, by the way, took us many hours without seeing significant failures or misconfigurations. But then, looking at the operator page, it's been described that the operator relies on the etcd raft election to select its own Postgres cluster leader, and that if etcd leader changes, the Postgres one does so as well, effectively restarting the SQL cluster. So imagine one SQL cluster restarting every few minutes. So it was there when we started turning our heads to etcd. In bingo, weird log messages indicating that the request for executing tasks were taking too long, and heartbeats were missing, suggesting that the server was overloaded. So here in this context, what is exactly to be overloaded? So in theory, etcd provides a stable, sustained high performance, and two factors to define performance here are latency and throughput. And latency is the time taken to complete an operation, while the throughput is the total operations completed within some period of time. So in basic terms, we can see as how fast or slow the data is transferred and how much data is transferred in a fixed amount of time. To compare, usually average latency increases as the overall throughput increases. So the more data, the more latency. Normally, a 3-member etcd cluster finishes a request in less than 1 millisecond under light load, and can complete more than 30,000 requests per second under heavy load. But raft operations to elect leaders and the normal etcd usage also impact the system overall latency and throughput. And etcd is very sensible to that. For example, the default etcd heartbeat is done every 100 milliseconds, but high latency could impact this heartbeat, right? And if the heartbeat is missed, then there's an election of the new leader, which during the process, the kube-api server that interacts with etcd misses the etcd heartbeats, and that is translated to failures in other applications that relies on this, like the Postgres operator cluster. So that's how we get to the problem of the cluster. But what did we do to confirm how bad we were? Turns out there's a benchmark tool that comes with etcd for measuring this. And in infrastructure, benchmarking is normally associated with measuring and comparing the outcomes of different indicators. So in this case, this benchmark tool is a CLI binary that allows to obtain indicators for read and write operations in an etcd cluster specifically. We can customize the desired number of connections, the number of the clients, the size of the data packages that we're sending, and also if we want to measure connections to just the leader or all of the members. And for read operations, we can also specify if we want serial or linear data consistency. So here in the pictures, we have some examples of the commands that we need to use. And as a matter of fact, I've created a gist here with some commands in case you want to download them and set your own etcd cluster, benchmark it, and play with it in your own machines. In case you want, it is gist.github.com/snwbr. So when we did our benchmark test, we got results way below the expected minimum performance we needed for the application to work. And by the way, these aren't the results we got in real life because of confidentiality, but instead, this is a test I did with a cluster trying to emulate what we had. And it's important to mention that this cluster on purpose has HDD, hard disks, for the sake of the presentation. In the etcd documentation, there's also an example of the performance that is achieved in average using specifications like the ones in the top right corner here. So for the presentation, let's use this box here as the architecture desired performance that we want. We all need to design the performance that we want to when we are designing a system. So what we see here are the right results. At first glance, we don't observe big differences in the requests per second, which is the throughput, and the average latency per request. The throughput, when you have one client and go directly to the leader to write, is not that bad. However, it is especially noticeable how throughput goes down to less than 10K and latency goes up to 95 milliseconds when we start sending 100K keys write requests to all of the members from 1,000 clients. The throughput is 5 times less and the latency almost 5 times slower compared to our desired performance. Talking about read performance, we are even able to split it by linear and serial requests, as I mentioned before. Very quick. Linearizable read requests go through a quorum of cluster members for consensus to fetch the most recent data. Meanwhile, serializable read requests are cheaper and faster because they read from any single etcd member instead of a quorum of members in exchange of possible serving stale or all data, right? So we got similar results for one client, one connection, as we did before with the right performance. But also, the throughput goes down and latency increases the more clients and connections we have for both linear and serial requests. So we can definitely state that we have a problem with etcd performance and its issues with distributed requests, because when we are seeing a lot of clients and a lot of requests, we are seeing the low throughput and high latency. And that's probably a bottleneck of on IO resources. What did we to overcome this? Well, we did then a correct analysis on the throughput and latency needed to this in the system to work on-prem, validating etcd performance after the suggested changes. Which changes? Those included replacing the HDD for SDDs, solid state drives, with higher performance, because we didn't even were aware of the HDD at all. But in case replacing them is not possible, we still have a few things we can do to improve the overall performance, like sticking to the minimum recommended requirements. That includes 2 4 cores, 8 gigs memory, ideally SDD, as I said, but if we use HDD, hopefully they are at least 15K RPM, and also minimum of 1 gigabit Ethernet network, the minimum, because the network can affect the latency and throughput, right? Because this is a distributed system. It goes through network. We can also configure the etc disk priority using tools like Ionize, so that when etcd writes to disk and there are other processes competing for resources, etcd has a higher chance to write first. And in this line of configuration, we can also configure etcd settings like timeouts and heartbeats frequency. And it could eventually help with less frequent heartbeats and then lowering the chance of triggering leader elections. With the caveat, of course, that it will take some more milliseconds to react to a member loss. And finally, we can use some other useful benchmarking and testing tools for addressing performance issues like disk benchmark, which is a complete toolset for measuring latency on disks. Remember that benchmark here is what was etcd, but disk benchmarking is also for disks. Also, FIO for simulating IO workloads, and the node conformance test framework by the Kubernetes community for system verification and functionality test for a node. So that's what I wanted to show today. I hope you enjoyed the use case and the proposal of using benchmarking tools if you suspect of a performance issues. By the way, here you have my LinkedIn profile in case you want to stay in touch. I always welcome everyone here. And thank you again all for your time and for giving me the opportunity to show you all this. Appreciate it and have a good one.
Okay, thank you, David. That was a really nice presentation. Guys, now this is your time. We're going to give a few minutes if any of you have any kind of question. Actually, I put my own in the chat. So if any of you have any question, please ask in the chat or directly, or raise your hand and ask directly to the presenter. So.
Okay, I can get the first question. What tool?
Yeah.
What tool are you using to get this data? Well, that is called benchmarking. I mean, the benchmark. The name is benchmark, but that data, let me share. Let me share because talking without using the actual response. This data is being get from the benchmark tool that comes with etcd.
Okay. All right. Yeah.
Yep.
So that's the benchmark tool. Okay.
Yeah, that is benchmarking for etcd specifically. If we want to do benchmark for disks, the whole disk, we also have the disk benchmarking as the presentation.
All right, great. We have another question by Yojiro Imaya in the chat. So could we feed into visualization tools like Kibana, etc., to get charts and graph as well? That's a good question.
Yeah, because as you can see, this is a CLI, right? This is a CLI that we have here.
What kind of output actually those that produce? Can you format it?
Yes, well, I formatted it here pretty quick, but I can show you a real life example because I was running tests here. Let me show you. I have some here like this. This is the outcome. So we have the summary. Also, we have response time histogram here to see at which time the more requests were served. So we can see bottlenecks or things like that. If it is sustained here during the whole life cycle, then we know there's a problem. We also get the distribution, how many requests were done and how long they took, right? So this is the output of the CLI. So if we get this into a log and then into Kibana with Elastic or something, or Graylog or anything else, we of course can get charts out of this, right? I would probably run this from like a cron job or something if we want to do this frequently. That I wouldn't recommend because that's payload to etcd, right? But if we want to create charts and run this every few, I don't know, minutes or something, of course we can get this data and put it into any tool.
Okay. Yojiro, you asked that question. Do you want to elaborate? You have your...
Yeah, hi, my name is Yoji. So it looks like you put in a lot of work to get this result. And I appreciate that. I think my other question was pretty much that. How long did it take for you to create or simulate this whole thing? You said this was done in the simulated environment. Is that correct?
Yes, correct.
And you kind of probably had to recreate the whole thing on your own.
Well, for doing the benchmarking exercise here, I just created a single cluster. Few commands that you can find in the gist I shared. Okay. Everything I got here in the presentation was done with the commands in the gist.
Right.
I can give it to you if you want to. It took like probably less than a day because I already knew, right? But in the real life, when I was doing this troubleshooting, it took more time, right? And that's what I wanted to say. I mean, my own experience that took time, I wanted to, if it happens to you, it could be actually, you know, less time that you take doing this, hopefully, right?
For people who doesn't know much what you're doing, so the learning curve is pretty high.
Kind of.
Okay, I guess it depends on how much you know, but yeah, I'll take a look at the document.
But you know, even though the learning curve can be high, there's always something that you can take from any talk, right?
Yeah.
Because now you have the benchmark mindset that you need to test latency and throughput in everything you're doing. So that's a good thing that you can take, and it is not that, you know, to dive into Kubernetes or etcd.
Right. All right. Well, I appreciate it. I'll look at the document, find out what I know and what I don't know, and I'll take it from there.
Okay. Okay. Thank you. Yeah, we have a couple more questions and then we need to go to the next presentation. So Simon actually asks, what actually was the solution in your case that completely solved the problem? HDD to SSD or what?
Yeah, for us, we replaced the HDD for SDD. We also increase a bit the CPU and memory, even though etcd is not that intensive on those matters. It is more sensible to storage and network, but we also increase that. And also we lower the heartbeat a bit. Okay. Because by default is 100 milliseconds, every 100 milliseconds, but we drop it to 200 milliseconds, and that worked because we wanted the heartbeats to be there and not be missed, right? And that made the trick.
All right, thank you. And Purnashi is actually asking, what is maximum cluster size?
That is for etcd. That is not benchmarked exactly, but I read it is, in theory, it is infinite because there's no like a cluster maximum size. They say in their docs the number is infinite, but we know that nothing is infinite here. So they don't give any specific number, but they say it can be a lot. But they don't recommend that much. They recommend a maximum of 7, I think, because when you have a lot of, this is Raft, okay? There's elections, and normally you want an odd number of members for elections to happen, 3, 5, 7, 9. But the more servers you have, the more time the elections are going to take. That's time consuming. So with 3 clusters, 3-member cluster, it can tolerate 1 matching failure. With 5, it can tolerate 2. With 7, it can tolerate up to 3. So that's the idea you need to take into consideration when designing.
All right, perfect. Thank you. Yumit, you can ask your question at the end of the presentations. We get out of time. We need to go with the next
But
meeting. So
the answer is fast. Can you increase the number of master? No.
yeah. So do you want to answer now? Can you increase the number of master node? Maybe yes or no? Oh, no. Okay.
Basically no, because the master is one.
Okay. Then it was super fast. Okay. Thank you, David, for your wonderful presentation and your
Thank you.
answers. We need to move on, so let's continue with Try, Don't Repeat Yourself, CD with GitHub Actions and Terraform by Juan Carlos Valderrama. Juan Carlos Valderrama is one of our solution architects. So Juan Carlos, please, the stage is yours, so you can begin now. You are on mute. We cannot hear you.
What about now?
Yeah, now it's better.
Great, thank you. Well, hello everybody. Just like Miguel said, my name is Juan Carlos Valderrama, and I do belong to the Cloud and Devops community team here in Malaga, Spain. Today we will talk about a solution for don't repeat it yourself effort, a paradigm inside of the software development that encourages us to avoid repeat our efforts in an endless loop. All right. So basically, the solution is trying to cover the avoidance of unnecessary efforts when a customer comes to us and says that everything needs to be done faster in infrastructure as a code, right? When a customer usually comes to us, the rush, the pressure of the business, and the time usually force us to create concurrent solutions, very similar concurrent scripts. We take one script and we change it for a new one with similar approaches, and we start creating then a bunch of custom scripts, but based from one basic script, and we are repeating ourselves the same effort with incremental changes, right? Usually we tackle that kind of problem by making versioning. And don't take me wrong, making versioning is the right way to do it. But the problem is how to not fall off in a problem in which you increase your scripts, you increase your version with incremental changes that are not significant against the baseline. I'm talking here about the infrastructure as a code scripts. So for that, I will show up a creative way to use GitHub and Terraform to handle those kind of situations by controlling the TF state file, which is the core of Terraform to control the infrastructure redeploy. In our agenda, we will have 6 points. I will explain the solution in overall, how it works. Then I will split the part of GitHub. Then I will go to Terraform and explaining how the workflow works. And finally, we will see it in action in order to show up to the audience how to control with one file and too few changes in the script as much as deployments as we want, no matter the environment, no matter the user that wants to deploy that, right? So let's move on. Basically, the solution is composed as the image shown on the screen. We have GitHub Actions. To use GitHub Actions, we need mandatorily create a folder called .github.workflows, and then we have to include our YAML file inside, which will contain all the GitHub workflow that we will run with the action. In this case, I create a menu just to show up how this can be handled in a graphic way instead just a scripting way. That menu will call Terraform into a runner, which will not be customized. It's a standard runner inside of GitHub. And such runner, after settle up all the environment in Terraform, will look for inside of Microsoft Azure. In this case, I'm using that cloud to control what is deployed, even if it's new or not. And as soon as it's making the registry inside of the environment in Terraform, the deployment will be done. This process can be repeated as many times as you like, just by changing the inputs of the Terraform modules. In summary, the solution then is using Terraform modules, is creating a TF state file that can segregate the deployment and the environment, so we can run the same deployment as many as we want in one environment, or we can create the same deployment in different environments, but by just segregating the Terraform TF state file with a couple of clicks. Also, it includes a menu, just like I mentioned, and as a good contribution in this creative way of working, I'm using environmental bars or TF bars, as well as nest loop in Terraform. Yes, I'm using nest loop inside of Terraform to read a object mapped variable, which is not easy in the common way of the infrastructure as a code, right? So let's move on. How GitHub Actions works for this solution. Basically, you run a menu. In that menu, you will define how your deployment will be named, and then the environment. This will trigger then all the Terraform environment, in this case, the client and the Terraform init and the Terraform format as unit testing of the Terraform script. After this, I will prepare the target environment by using Terraform workspaces. This will help me out in Terraform to segregate the deployment based on the environment. Implicitly, Terraform will create then another TF file pointing to that environment and naming it as the workspace. And finally, it applies the change. In additional, the part of Terraform will call the Terraform model, okay, from one folder to another, and will create on the fly another backend file. In this case, when we create the backend file, we will segregate then the script, the TF file, and the environment with a minimal change of code. In fact, we will see in the demo that the only changes that I want for the same resource are only required in the input parameters, no more, no less, no more code, right? And of course, as a best practice, Terraform script will tag the resources and utilize the nested loop algorithm that I run inside of Terraform to take an object map variable created into a flat map variable and then read it and create concurrent resources. In the left part of the image, you can see how the parameters are named inside of the script. And please pay attention on those ones who says Q1, Q2, Q index, as well as the topic name one-to index topic, and the subscriptions. In this case, I decide to create a service bus, which includes the complexity to have topics and inside of the topic subscriptions. So we will create concurrent resources with the same code, okay? So far, there is any question from the audience? I'm checking the chat, and so far there is not. So I will run then the demo. Basically, I'm preparing here the environment. I create a PowerShell script that will create a resource group for Terraform inside of Azure. It will create a storage account. It will create a container. It will create a service principal with the proper authorization to run this kind of commands. And then I'm just publishing here the client ID, the secret, the tenant ID, and the subscription to make the deployment. This information will be saved then here in the left part of the screen in Azure GitHub Actions secret. You can see it in here in order to protect the execution from any external interaction different than the requirement for the business, right? Going back to the right part of the screen, you are seeing here the code, which is the input of the model. Pay attention, please, here, in which I'm just using as input parameter an object mapping variable. If you see, this object is having one variable and a list of variables to create concurrently resources, right? Of course, if you see the list of files that are inside of this demo, you can see here the traditional folder for models that is being used in Terraform as the mandatory guideline to run a demo, right? So let's run it. How I should run this? Of course, just like we mentioned before, I have a folder called GitHub workflow, and this is my YAML file in which all the process is written. You can see here the secrets call, secretly preserved in order to avoid any security compliance. All the process will run, and pay attention in the bottom part in which I'm sending the variables that I will catch from a visual menu, and such variable will be sent to Terraform as environmental variables to run the process. Let's run it, okay? First thing first, I already did the first running in order to show up the audience that everything works with one environment. So the first thing that you can see here is if you go to the resource group, the storage account, in this case, the container, as well as the container of the files, you will find out the Terraform files. In this case, Terraform will create per workspace another TF file that will help me out to segregate the environment for the deployment. Here is the first deployment that I made. You can see here, you can see the queues created, Q1, Q2, Q3, which can be seen here in the code, and the concurrent part, which is topic name and subscriptions. You can see it in here. You can see the topics. So you see card. Card, it is supposed to have update A, B, C, D, E. So if you click in here, you can see then those components already created in a concurrent way. Now let's run the process for a second way. This second way, I will run into the same environment, the process. So let's go to Terraform Apply, run the workflow. This menu was created inside of the YAML part in which I'm selecting the environment. I'm just saying which module we run. I will name my deployment, right? And just to be sure and avoid any error of execution, I'm just putting a yes or no. In this case, I will put yes in order to confirm my process. What I will expect then is two files again, but it will be called same m-2. You will find then the def and tf state in 2, and you will find too another service bus as well, the application inside resources. This will show up then that the same code can be used to deploy the same resource in the same environment with different name with no additional code. Right after this finish, I will do the same then in another environment to show you up how this same code can be used in a different environment or in the same environment as many times as you require. And the only thing that the end user has to do is to change the input parameters here under your work. In the meantime, this is running. I would like to know if from the audience there is any question that I can solve. In the meantime, the process run, any doubt or question that you have regarding this solution?
Yeah, actually not a question, but keep an eye on the timer because we are getting, we are leaving Kirill not too much time for his talk.
Sure.
Right.
Sure, Miguel. We will finish in here. So basically what the process is doing then is applying all the components and services. And if you see here, the files appears again. So we are running the same component, but using two different deployments into the same environment. And just considering the time constraint that Miguel is saying, I will not run the different environment because it's pretty much the same process, but using a different menuing. And there you go. This is so basically what we did. What we did then was to create a solution in which we are applying the immutable infrastructure approach in order to help the teams not to get focused into the infrastructure, but also the work. Let us to work in the infrastructure to us. I automate repetitive and time-consuming tasks, right? Using by don't repeat yourself approach. And I'm keeping away the infrastructure as much as possible from any manual configuration, okay? Your Terraform backend configuration, it is pointing to which if states. Yes, spreadsheet, of course. Just give me a second. What I usually do here is with my script, I create a backend, right? So my PowerShell script, after to create the storage, he write down the backend file, right? And if you see, let me show you. If you see my Terraform apply, what I do inside of my Terraform apply is to rewrite only the part that I need inside of the file by changing. Let me show you here by changing only this part. Only this part. All right. So I've changed this text on the fly. I'm not corrupting anything. And the outcome is always an endless way to run the process, to run as many deployments as you like. You see now I have two, and I have two different deployments into the same environment. If I run a third time this, by using another environment, for example, by using, let me show you. If instead of that, I just write down different environment and use staging, there you go. Another file will appear here with such deployment, so you don't need to write down everything. Luis, can we trigger it automatically? Yes, of course. I'm doing it manually here because of demo purpose in order to show all the flexibility. But yes, you can trigger it, for example, with a push, with a pull, with a tagging, as many options as the GitHub action has. Armando says, did you think about the possibility of inserting at the beginning of the pipeline of the creation of the backend storage account and getting the name? Yes, you can do it. But it will take more time to do it so because every time that you have to rewrite it, you need to use a different workflow. So in this option, I'm just using one workflow for everything. Alex, I said, I understand your idea about the DIY correctly. You may use Terraform Workspace instead. It will be more Terraform native solution. Yes and no. Because the utilization of workspace is only allowing you to use these two files. If you add the complexity to, for example, deploy in an ordered environment, just like a different resource group, you need to use GitHub Actions for that and segregate this. And please consider, if you use Terraform for this, let's remember that Terraform will write down the name of the file, just like the deployment. Every time in this solution, every time you name the solution, name the deployment, you will create a new Terraform state file. And if you repeat the name, you will update that deployment. Right? Yeah, I'm done.
So, Juan Carlos, yeah, we are getting out of time. If there is any more questions for Juan Carlos, you can actually ask in the end of the meeting. Okay, we will stay here a bit to answer any question that you can have. Okay. So now, next of our speakers is going to be Kirill. Kirill Bogdanov is one of our security architects. He's going to talk us today about protecting container-based solutions in Azure, and he's going to give us an overview about community tools versus. Okay, so Kirill, I'm sorry because we gave you not too much time, but yeah, let's go.
I'm actually sorry for our listeners because that's not my giving me less time. It's getting more time from them. But yeah. Okay, I'm Kirill Bogdanov. I'm a security architect from EPAM security practice, and I want to talk about protecting container-based solutions in Azure. The origin of this talk was one situation when a customer asked us to provide ideas on protecting their container-based development and infrastructure implementation, and assess possible tools and approaches to mitigate the most common threats they have usually on this way. So let's start from the scratch and talk a little bit about container lifecycle and threats and controls we have to mitigate them generally. Basically, we have a developer who will develop some solution based on container, and while there is an existing approach to get some kind of optimized Linux image like Alpine and build a container from the scratch, we see that it's not the general rule. In most cases, there is some baseline used that is being got from public container registry, or even if it's made from the scratch, there would be some external dependencies and libraries used for the sake of optimizing the code and not doing more work from the scratch. So we get the traditional problem of supply chain attack vector. The container could be vulnerable, could contain malicious image, could contain, again, dependencies with known vulnerabilities, and everything becomes our problem and way the attacker can get into our infrastructure. Besides that, we get developer errors. Developer can introduce vulnerabilities due to lack of knowledge, bad coding practices, not knowing some details on how technology works. For example, if we do not think about the way layers within the container work, we can assume that deleting information in one of the steps would be enough to protect it from disclosure, while actually we still can reverse engineer the container and get confidential information from every layer if it was left there. And at that moment, our first helper is security linter. So the same way linters work for adhering to coding best practices and style sheets and coding styles, we can have specific IDE plugins or tools that integrate with developer environment that will guide us on the most left side of the process, helping to avoid general errors and adhere to the best practices for containers, for example. Then we will upload our image into trusted registry, and it could be not only the source for running the productive environment, but as well as a source for the future development work instead of getting it from public containers. But we should think about the ability to introduce vulnerable containers there as well, and we need to assess them continuously. Besides that, Docker files the configuration that instructs container infrastructure on how to build the container and what should be there could be propagated through version control system for control, and problems like leak of secrets in the build files could be pretty regular there. And at that moment, we generally look into software composition analysis solution. Those who will build our software bill of materials, our dependencies, and inspect them for known vulnerabilities or updates and so on. And static security analyzers that will look through our image or Docker file for config for known bad patterns that again can lead to vulnerabilities and become a threat attack vector. Finally, our image gets into some kind of container host that will run our workload. So it can be some kind of orchestrator like Kubernetes or standalone host. No matter what, the vector would be the same. Basically, we have ability to attack a payload, and in case the payload works or has some errors within that, it will affect our capability to be efficient with payload, or even provide footprint for an attacker to have further steps within their attack. And if we got wrong with daemon configuration or host configuration, vulnerabilities in this part can lead to sandbox escape and privilege escalation for the attacker to become the first step for internal reconnaissance and moving further within our infrastructure. So at that moment, we're trying to mitigate this with dynamic security testing to identify possible problems earlier than an attacker, and do everything to protect host, like hardening, removing unneeded services, setting up malware detection, and other means like whitelisting to protect from doing wrong things on the host, as well as while we're providing feedback loop for developer on performance issues, bugs, and possible functional updates, we should have the same for security, using security monitoring, some kind of host-based intrusion detection solution or endpoint detection and response. So if our protection mechanisms were overcome, we still be able to detect and react accordingly. On the way what we used as a benchmark for assessment and what was our North Star, we used two parts. First of all, it's this benchmark for Docker from the Center for Internet Security. It's rather comprehensive document that covers all the infrastructure layers from host configuration to runtime monitoring, and as well best practices for writing Docker files. It's a set of documentation on Docker community that provides best practices and methods for building efficient images. It's not specific for security only. The there is a number of, say, the majority of information is devoted to how to make them more efficient, less, make it, have it a smaller footprint, and more doing more in performance style, but still there are some recommendations that are devoted for security as well. Speaking about tools, we were looking into 3 community tools like Docker, Huddlint, and Docker Bench for security. And for the fact that the customer had their cloud infrastructure standardized on Azure and full coverage of Azure Defender, we tried to identify what this solution can provide us for this case. What areas would be covered and what capabilities are there. So it was Microsoft Defender for Cloud, with Defender for Servers, Defender for Container Registers, and Defender for Kubernetes. The last 2 are deprecated as of now and exchanged into Defender for Containers. So let's have a closer look. Docker. Docker is a container image linter that focus on image file scans. So it covers partially this benchmark, as it doesn't look into host daemon configuration and so on. Additionally, it has some original checkpoints based on best practices. Sometimes they can be a little bit outdated, and internal documentation has a number of situations when there is a pretty hot discussion on should one or another checkpoint be used. It's CI suitable, so you still can easily integrate it into continuous integration pipeline. And what we supposed to be pretty mutual metric for open source tools is the version and number of contributors. For here, the version the tool has 35 releases, with the latest just a week ago, and there is like 30 people working on this solution. So seems like it's pretty legit from being as a base for future strategy. The next one is Haskell Docker file linter. Is as the naming says, linter for Docker files with specific focus on Docker files only. Mainly, it's based on best practice for writing Docker files, so has like little coverage for this benchmark. It's suitable, but we've seen that it is best used as a part of development infrastructure on the development environment. Docker Bench for security. While 2 previous solutions were binary files, Docker Bench for security is a set of shell scripts that just encompass the whole benchmark for Docker for automated checks. For those points where automation is not available, because the benchmark has a number of recommendations that should be assessed manually or taken in consideration, it will provide a recommendation and highlight this topic for manual assessment. Shell, as it's shell script based, it's easy to configure and alter. And that's the reason why it requires pretty high privilege for host level scans, or otherwise it will not be able to check the information. That makes it less suitable, from my point of view, for continuous assessment, but one-time assessments could benefit pretty much from that. There are something like 60 people working on the solution with only 8 releases as of now, just because every release is based on new releases of Docker benchmark. So there's less sense to have some preliminary or interim releases within. Talking about Microsoft Defender, we used, as I've mentioned, primarily two components. It's Defender for Service for host hardening, threat vulnerability management, endpoint detection and response, as well as Defender for Containers that is working as acting as SA and SAST tool for images in the registry. And besides, it provides host security monitoring and runtime monitoring for Kubernetes environments based on Azure Kubernetes or any other solution, while Microsoft Defender for Cloud provides single pane of glass for reporting. So you have all your recommendations, vulnerability, and alerts in one place. That is pretty useful for security teams and security champions within the development teams, as well as unified API to connect all these things together. What we've done, we just set up a document with all the recommendations and controls from both sources, and then manually assessed the coverage for all the tools. And we got the following findings. First of all, Docker Bench for Security and Microsoft Defender for Cloud provides the best coverage for this benchmark, basically because the first one is built around that, and the second one, like Microsoft Defender for Cloud, sets as an internal standard that they require coverage of 100% since benchmark requirements here. Talking about two other solutions, Huddlings showed up to be rather useful for adherence to Docker best practices than security, but still, you know, there is a number of settings that are like connected. You will get bad performance, and it will create additional problems with availability, for example. So that's a part of security in turn. And speaking about Docker, we found it pretty good lightweight solution working on leaking Docker files. And what it was most interesting for, and we are really amazed with, it's a password search feature. So it has built-in capability to look for secret strings, passwords, and connection strings within the Docker file, providing specific patterns. And if I remember, it was like regex or something like that. And moreover, you can alter this capability to add some patterns that you know you are using a lot within your infrastructure. It will not cover 100% of cases, but it's pretty good for the most popular ones. So getting into the results, there is no silver bullet. Actually, we should assume that there is no solution that covers the whole process for all the parts, because again, there's a plethora of different threads and different moving points where you need to provide control. So it's not easy, even with a technology suite, to provide solution that will work ideally for all the cases. You should always consider defense in depth approach and use multiple layers of protection. Open source tools can be stacked precisely for optimal coverage and flexible and sensible integration capabilities, at least the ones we were looking at and using there. Again, just because it's a pretty small footprint, they are fast. You can call them throughout your pipeline with minimal addition of time for a run. And you can tweak them to cover just pain points you really need. We've seen really good results integrating Huddlint on the developer workstation as the first point of protection, or at least guidance. And I will not be able to stop being amazed with password search capability within Dockle. It's really worth to use it for this option alone. On the other hand, Microsoft Defender platform provides integrated solution with unified reporting and APIs, and it can provide additional value for more broad security team, not only security champs within the environment who are looking into automatically created Jira issues or some comments within the updates on the version control system. But we need to understand constraints and specifics. For example, if we are talking about Defender for containers, while it provides SCA and SAS capabilities for images, we should understand that first we get image into the registry, then it's being scanned and then highlighted if there are some problems with that. So in case of using it as the main solution, we need to have additional container registry for production environment and some gateway and manual or semi-manual process for moving clean images from development to production based on the result of assessment. It's not as easy as being used in traditional pipelines where you just have some interim gate that will be more failing or providing operation. And again, feel free to combine tools for maximum synergy. That's not the one way or another. You can easily use both solutions to get the best of both of them. That's all for now. Thank you, and I hope I haven't taken too much time for that. Let me get back into questions.
All right, thank you, Kirill. I think there were only one question. On top. Yeah, so they were asking about actually license for Docker, but they were that was answered in the chat. So guys, is there anyone that actually has any kind of question for Kirill, or are you already super tired? It's a little bit late. Sorry for being like 10 to 15 minutes out of time. If there is nothing, okay, let's I think no one is raising the hands, nothing in the chat. So thank you, Kirill, for the presentation. It was a great talk, and let's do a wrap up here. Yeah, guys, we are going to actually make the recordings materials as much as we can available in the platform. All right, so wait on the next days for actually an article in the We Are community platform with all the necessary materials. Okay. Also, I would like, if any of you is interested in actually do a presentation, all right, It's super easy. Don't be afraid of it. I know that there are a lot of people in this one, but actually no one actually complains, as you see. So don't be afraid. Think the main benefit that you will get is think about yourself in 10 years, what you are going to be done. And probably you are going to actually do lots of these presentations in your career in 10 years. So this is a good opportunity to actually practice and get experience. All right. So if you have something interesting to actually give a talk, or if you are interested in actually give talks, but you don't have an interesting topic, please come to me. I will give you either topic or actually, if you already have a presentation in mind, just to add you to the group and you will be able to present on the next ones. All right. Apart from that, yeah. Thank you to the wonderful presenters that we have today. The three of them actually gave really interesting presentations. There were a lot of interaction in the chat. So thank you guys for taking the effort to actually share your knowledge with us and with the community. And also thank you. I want to thank you, all of you, for actually joining us today. This was, as I said in the beginning, our first gathering. I hope that in the future we will do it better, with more time to actually do advertisement, with more probably also being able to actually physically gathering in the Malaga office. So yeah, feel free to join us in the next ones that we are going to do in the future. Probably next one is going to be in September, so keep an eye on the community page. If you already joined the community, you will get an email when we are going to have the next one. So keep an eye on it. And yeah, nothing much to say. Thank you all for coming here today, for being patient until the end, and see you in the next one. Okay, bye.
Bye. Thank you.
Thank you. Bye bye.